Solving another set of problem with method of substitution. So 3dx over sine square 1 minus 4x. And before we start, let me write down the formula that is very important and widely used, especially when we are doing method of substitution. So integral f of x dx is equal integral f of ax plus bx plus b dx, and that is equal 1 over a uppercase f ax plus b and plus constant plus c. So we can write down here equal. So what's going to happen? This 3 comes out, right? Integral. We have here sine squared 1 minus 4x, right? On the top we have dx. To be able to integrate, we either sine square has to have x, or dx, the x under this d derivative gonna have 1 minus 4x. So we can integrate. So what I'm going to do now, I'm going to write down, instead of x, I'm going to write down the derivative 1 minus 4x, squeezing underneath. Why? Because if I go backwards, derivative of 1 is 0. Derivative of negative 4x, look, let me do it here. d 1 minus 4x dx, yes? So derivative of 1 is 0. Derivative of negative 4x is 4, and derivative of x is going to be dx, because we don't know what is under x. So the 0 is gone, this negative 4 dx. So we're getting same thing, and this 4, because it's we are squeezing additional negative 4, I'm going to also multiply by negative 4 in denominator, which is covering right here this formula. See here, we have ax and coming out 1 minus ax, 1 over a, because we squeezed in this a multiplied by x. Therefore, we divide by 1 over x, a, right? So this is we have. And from here, we have 1 over 3 over negative 4. Integral 1 over secant is the 1 over secant squared, right? Is gonna be cosecant squared, correct? Squared 1 minus 4x d 1 minus 4x, and the answer is going to be 3/4 cotangent 1 minus 4x plus c. Why is that? Based on formula that we used, that integral cosecant squared x dx is equal negative cotangent x plus c. Okay? So, oh, I said negative and I didn't put negative. Okay, so let me move this here. And we have the first one. Number 2, integral tangent cube x dx. Okay, so I'm separating tangent cube and rewriting tangent square times tangent x times, and tangent square, it's going to be sine square x over cosine square x and dx. And then we have tangent x. So we rewrite sine square x, it's going to be 1 minus cosine squared x, right? Because of formula. Sine square x plus cosine square x is equal 1. So therefore, here we have 1 minus cosine square x over cosine square x and dx. Okay, the result from here is gonna be, we have tangent x, and then 1 over cosine square x minus cosine square x over cosine square x and dx. So this is equal integral tangent x 1 over cosine square x minus 1. Next, it's going to be integral tangent x 1 over cosine square x dx minus integral tangent x dx. Okay, so 1 over cosine square x is secant square x, right? Secant square x dx, degree 2, it's not working for me. Okay, and minus, well, integral tangent x dx, that's the equal, let me write down here separate integration formula. Tangent x dx is equal negative natural log cosine x I always squeeze in too much at the end. Okay, like this. Cosine x, okay, and plus c. So it's going to be here. Minus negative natural log cosine x. If we substitute tangent x as a u, right? So we will get u du and plus natural log cosine x plus c. And this is going to be equal u squared over 2, yes? Plus natural log cosine x plus c, which is tangent square x over 2 plus natural log cosine x plus c. So the answer is tangent square x over 2 plus natural log cosine x plus c. Okay. And lastly, let's solve this one. Integral dx over sine x degree 6 is equal. So what I'm going to do, I need to do some manipulations, which means I have here dx sine degree 6x. So nothing will happen if I put here 1, right? The thing is, because I have sine to power 6, there is nothing much to work with. So I'm going to manipulate with 1, which is, we know, sine square x plus cosine square x is equal 1. So I'm opening up like as the following. Sine square x plus cosine square x over sine degree 6x and dx. Okay, so when I divide now, I'm going to get sine square x over sine degree 6x, and then plus cosine square x over sine degree 6x dx. Now the thing is, I'm getting much difference between degrees. See, I have here degree 2, here I have 6. Same thing with cosine and sine. So difference between them 4, so that we don't know formula with degree 4. But what we do know, we know formula with degree 2, right? Where sine square or cosine square. Therefore, what can I do so make smaller this the degree 4, make it degree 2? Very easy. Look what I'm going to do. Now, in numerator, I put down sine square x plus cosine square x, and everybody agrees that it's equal 1. Now, let me ask you, and when I say now, everybody will say, ah, now look here. If I take 1 to power 2, is it going to be still the same 1? I see you are smiling. Of course, it's 1. So, which means what we are going to do? Same, I can take it also to power 2, right? Because if sine squared plus cosine squared is 1, the square also going to be 1. But if I open formula a plus b squared, I will get a sine to 4, I will get cosine to 4, and difference I'll bring to degree 2. And we will be easy to manipulate there. Okay, let's do it. So, this is equal integral, it's going to be sine degree 4. I'm opening formula a plus b squared, yes? You remember, a squared plus 2ab plus b squared. Okay, so it's going to be sine degree 4 plus 2 sine squared. Look how nicely it's coming out. 2 sine squared cosine squared gives you also sine squared cosine squared, and plus cosine degree 4x dx, and we have sine degree 6x. Next, breaking down, same denominator, it's going to be sine degree 4x over sine degree 6x dx, plus 2 comes out, so 2 gonna be sine square x cosine square x over sine x to power 6 and dx. And from here, what we can do here, okay, sine square x is gone, here is 4. All right, since I did here, I can do the same thing with this integral. Sine to power 4 is gone, here is 6 will become 2. Okay, and then plus integral cosine degree 4x over sine degree 6x. Okay, so we have integral 1 over sine square x dx plus 2 times cosine square x, break down here sine square x and then times sine square x dx, and then plus, same way, oops, here dx, and then plus cosine degree 4x sine degree 4x, and then sine square x and dx. So 1 over sine is cosecant, so 1 over sine squared, it's gonna be cosecant square x dx plus 2, here we have cotangent, right? Cotangent x, cotangent square x, and then times 1 over sine square x dx, and plus, what do we have here? This sine square x is gone. Oh, I'm sorry, I put on the top also sine squared. All right, so yeah, that's what I wanted to do here. I have cosine over sine, and it's gonna be integral cotangent to power 4x and 1 over sine square x. Let me this square also write down clearly. Square x dx. Okay, next, we know that based on integration formula, integral cosecant x dx is equal cosecant square x, I'm sorry, cosecant square x dx is equal negative cotangent x plus c. Because integral only cosecant, it's a different story. It's a negative logarithm of secant plus cotangent, so it's a longer story. But cosecant square is shorter, easier, that's cotangent. Okay. All right, so from the first one, integral, we are going to get negative cotangent x, right? And this is what I'm going to do with the second integral. So substitution, t is equal cotangent x. So from here, dt is going to be equal, derivative of cotangent x is negative cosecant square x, and we don't know what value of x has, so we put dx, right? And let's look here what we have. So since we need negative sign, I put here negative also, or let me just put this negative, put different color so you can see, guys, where from it's getting in. Okay, and we have, since we have cotangent square, so we're gonna get t squared and dt. And same thing I'm going to do with the second integral, which is going to be t to power 4, because if I mark down cotangent x is equal t, then cotangent power 4 will be t to power 4, and also cosecant squared dx, negative cosecant squared dx, and same way it's gonna go subtraction instead of addition because of this negative sign we have. We need to adjust this negative sign. Okay, so we get dt. All right, so from here, final result is negative cotangent x minus 2 the t to power 3 over 3, right? And minus t to power 4 over 4 and plus c. And as a result, if I plug in back, I'm getting negative cotangent x minus 2/3 t cubed. It's going to be cotangent cubed x. Okay, let me bring it down. I thought there is something at the bottom and there is not. And minus t to power 4, it's going to be cotangent x to power 4 and divided by, oh, I'm sorry, what am I doing? I'm in a hurry. I have some work starting in a minute. Sorry, hold on. It's 5. And I'm getting cotangent square 5 divided by 5. That is correct answer, M plus C. So the answer is negative cotangent minus 2/3 cotangent cube x. Is it seen that I'm in a hurry? Minus cotangent x degree 5 over 5 and plus c. Sorry for these mistakes. I'm done, and I'll see you tomorrow in next video. Thank you for watching.